So in lesson 3.7, we're going to be looking at some inequalities that are in a similar format as those two-step equations that we've been looking at. So you can see this unit is called solving ax plus b is less than 6. Could be greater than 6. And the big idea is that inequalities that are in this form, ax plus b is less than or greater than c, they can be solved in two steps, similar to those that we were solving with an equal sign that were already in that same form. So you're going to eliminate the letter that's kind of by itself, and then you're going to eliminate the letter, which will be a number that's also attached to your variable. So let's jump right in. So example number 1, we're going to solve this one and we're going to graph it. And then we're also going to perform two checks. So there's two checks for each one of these. So the big thing that you want to remember is that our inequality is going to flip one way or the other if we multiply or divide by a negative. If we don't, then everything's going to stay exactly the same. You keep the variable on the left side or the right side, wherever it is, and you keep the inequality, the less than or the greater than, facing the same exact way all the way through, unless you multiply or divide by a negative number. So when we take a look at this, you still want to think of it like that's your dividing line, and you're trying to get the variable completely by itself. So in this case, my variable is letter B. It's on the left side. So to get rid of it, to get rid of the 10 and get the variable by itself, I'm going to minus 10, and that's going to clear it out, leaving me just 4b is greater than negative 4. And now this says times, so I'm going to divide to get rid of it. And so b, now a lot of people at this point that make the mistake of flipping say, well, I see a negative right here, but the number that determines if it's going to flip or not is the actual number that you're dividing by on both sides. Since it's positive, I leave this facing the same direction. Negative 4 divided by 4 is negative 1. So this is what I think the answer is if I put it on the graph. Here's 0, here's negative 1, here's positive 1. I'm going to go over to negative 1. I'm going to put an open circle. And now I need to determine, is it going to the right or to the left? So B represents the answer. The answer is everything greater than negative 1. So all the numbers greater than negative 1 are this direction. Make sure you put the arrow showing that the answers go past the end of your graph. And now we need to do two checks. Check 1 and check 2. Check 1 determines if our numerical answer of negative 1 is correct. Check 2 tells us if our arrow is going in the right direction, if our less than or greater than is facing the correct way. So first, we're going to check our answer of negative 1. So we're going to rewrite the original, but instead of greater than sign, we're just checking to see if it comes out equal. If we plug in this number, it should come out equal. So 4 times negative 1. Where'd the negative 1 come from? That was my answer that I'm checking. So negative 4 plus 10 equals 6. I get 6 equals 6. And I'm good. So that means the negative 1's correct, but that doesn't mean my answer is right. I could have this arrow going the wrong direction. So I'm going to pick a number that's in the solution set that I gave, like 0 or 1 or 10 or 100, and check and see if it makes this statement true or not. Now it should if my answer is right. So I'm going back to the original with the inequality still there, and I'm plugging any number in the solution set. So don't plug in the negative 1. It's got to be something in the solution set. So I'm going to go with the 0, just because it's nice and easy to work with. So 4 times 0 plus 10 needs to be greater than 6. Well, 4 times 0 is 0. So I get 10 greater than 6. Obviously, that's a true statement. And so I know 0 is supposed to be in the solution set. You could even do one extra set of checks if you really wanted to, and plug in a number that you know is not in the solution set, like negative 100. Plug it in and make sure that it doesn't work. If it doesn't work, then you definitely have that arrow going in the right way. All right, let's slide down to the next example. So on this one, we got some simplifying to do. Again, treat the inequality like an equal sign. That's your dividing line. So I've got an n over here and I got an n over here. Since they're on the same side, I can combine those like terms. Since I have the 2 and the 203 without any variables, I can combine those as well. So starting with these, I've got a negative 10n, and a 2 and a 203 gets me a positive 205. Keep everything facing the same way. And now, just with a little bit of combining like terms, I now have something in the correct form of the ax plus b equals c. So this is your a, your b, and your c. So I just want to get this letter by itself. So all I have to do now is subtract 205 from both sides. Bring that down. Don't do anything with that. 5 minus 205 is negative 200. Now I want to get n by itself, so I'm dividing by negative 10. So that creates a 1n. And I divided by a negative 10 on both sides. It's a negative number. Okay, this is that special case. And my sign needs to flip. So now instead of being open towards the variable, it's closed towards the variable. Notice I didn't move my n all the way to the left side. Even if I'm more comfortable with it on the left side, I need to wait till later, because right now I need to make sure that I've got my less than sign or my greater than sign pointed in the right direction. So it's open towards the n. I divide it by a negative. It flips. And now I divide here. 2 negatives make a positive 20. So this is what I think the answer is. If you want to rewrite it, you can put n on this side. But then if you're going to flip where n is, you need to flip the sign. And make sure if it's open towards the 20 here, it's open towards the 20 here. Or if it's closed towards the n here, it's closed towards the n here. That's the only way that you're going to ensure that these both say the same thing and they're equivalent. So if I'm going to put this on a graph, here's 0, here's 20, negative 20 would be over here. So this one has a greater than or equal to, or less than or equal to. So when I put this on the 20, I do need to fill it in. So 20 is included in the solution set. It should make this statement true. Now n is less than. All of the answers are less than 20. So I need my arrow going down towards the negative numbers. So now we got to check this twice. First check is just checking the number 20. So we're going to go all the way back to the original. We're going to see if it comes out equal. So we're changing it to an equal sign. Plugging in 20. All right, one step at a time. So negative 3 times 20 is negative 60. 7 times 20, 140. And now we're going from left to right. We're going to follow our order of operations. So negative 60 plus 2 is negative 58. Negative 58 minus 140. It's like combining two negatives. It's negative 198. And we know what we're going for, so let's make sure that it actually works out. We need 5 on both sides. If I combine a negative 198 and a positive 203, sure enough, that also equals 5. So I'm going to make a little bit of separation here, and I'm going to try and squeeze her in. Now I need to pick a number that's in my solution set to see if my arrow is going the right way. So I see the 0 is in my solution set. So that's the direction that I want to go for sure. So I'm going back to the original with the less than sign, and I'm going to plug in 0 for everything. So let's see if I can squeeze it. So I'm going negative 3 times 0 plus 2 minus 7 times 0 plus 203. So what's nice about this now is all of my zeros are just going to cancel out. So this becomes 0 plus 2 minus 0 plus 203. So 0 plus 2 is 2 minus 0 is nothing plus 203. So 5 is less than 205. Is that true? Is 5 less than 205? Well, of course it is. So I know that is good. All right, so that's just solving your basic ones. Now let's take it to the next level. Let's take a look at some word problems here and see if we can write an inequality and then solve it. So during a dry summer, the level of water at a local river decreased. That's key. When we're writing an equation or an inequality, we need to make sure we're going to use the right plus or minus, right operation. So decreased sounds like subtraction. 1.5 feet every week. It's going down 1.5 feet. The water started at 60, so I'm going to start writing this. We started at 60, and it's going down 1.5 every single week. If the water level is 30 feet or less, then a water emergency is in effect. Okay, so this is going to represent what the water level is at after a certain number of weeks. If this number is less than 30 feet, or if it is 30 feet, then we have an emergency. So we want to know how many weeks would a water emergency begin. So if this number, W, is less than or equal to 30, okay, now we have a problem. So let's solve this and answer the question. After how many weeks would a water emergency begin? So I want to get the W by itself. Now, a lot of people want to go ahead and add 60 because they see the minus. Minus goes with the 1.5. If I added 60 under 60, I get 120. That doesn't help me. So since it's a positive 60, you got to think about what's in front of it, a plus, a positive. Go to minus so that it goes away. Now this whole thing comes down, including the minus, which counts as a negative, so we can't lose that. Again, the only time we start flipping this is multiplying or dividing with negatives. So right now we're not doing any multiplying or dividing, so don't even think about flipping that around. And this is negative 30. Okay, so now we're going to divide. We want to get rid of this. So it's going to go away. Now we just divided by a negative, so right away before I forget, I'm going to come down here and flip this. I divided it by a negative, and now we're going to do 30 divided by 1.5, and that is 20. Two negatives make a positive. Okay, so this is what I think the answer is. W is weeks. I'm going to define your variable. So after how many weeks would a water emergency begin? We've got an answer on our page, but we need to interpret it. So we need to write a sentence that represents what this means. If weeks are greater than or equal to 20, then we have a water emergency. So we need to write that. 20 or more weeks will create an emergency. Now you can write that however you want as long as it makes sense. You just need to make sure you don't say just 20 weeks. You need to say 20 or more, something like that. Greater than or equal to 20. All right, going down to the very last question now. Example number 3. So it says in order to ship a crate of oranges, it must weigh more than 70 kilograms. If it's less, you can't ship it. If you're filling a crate that weighs 7 kilograms when empty with oranges that each weigh 0.3 kilograms, how many oranges must you put in the crate before shipping? Okay, so let's break that down. It's got to weigh more than, so the amount that we're going to write has to come out to more than 70. So this amount that we're going to create has to be more than 70. Not at least 70. There's not an equal sign. It says more than 70. So the crate itself weighs 7 kilograms. So 7. Plus, we're going to fill it with these oranges that are 0.3. And O tends to look like a 0, so I'm going to put an F for fruit. So F equals oranges. So every single orange adds 0.3. How many do I have to add so that the total weight, including the crate, comes out to more than 70? So let's solve this. So I'm going to minus 7. I get 0.3 F greater than 63, and now I'm going to divide by the 0.3. Grab my calculator, 63 divided by 0.3 is 210. I did not divide by a negative, so I'm not going to flip anything. So F is greater than 210. So the amount of oranges needs to be greater than 210. So that means 210 is not enough. If I use 210, that's not greater than, okay, that's equal to. So that would get us to exactly 70 kilograms. So if I use 210 oranges, I get exactly 70. But according to this, it has to weigh more than 70. So I need more than 210. So I'm going to say that the minimum number is what? Think about it. The minimum is not 210. It has to be more than 210. It's 211. So the minimum number of oranges is 211. Now, you could have said you have to fill it with more than 210, but sometimes that's confusing to use the actual number if it's really supposed to be more than. So you could say 211 or more or something along those lines, but just be careful with your wording when you write these out.